so question number 6. Question 6 says a car of mass 1800 kg is towing a trailer of mass 300 kg up a straight road inclined at an angle alpha to the horizontal where sine alpha is 0.05. Okay, so this is a case of connected particles. So we have a car of mass 1800 kg, we have a trailer of mass 300 kg, and sine alpha is 0.05. Okay, so what else could we do? Okay, then we have connected by a tow bar, light and rigid and parallel to the road, resistance. Okay, now resistance force on car is 800 Newton, and resistance force of F Newton on trailer. Driving force of car's engine is 3000 Newton. We need to find the acceleration and the tension in the tow bar. Okay, so these are the given things, so let's work on it. See, this is your inclined plane at an angle alpha to the horizontal. Okay, so this will be your alpha. Suppose this is your car. They don't seem to be on point, so okay, fine. So this is your car. Okay, how they are moving? They are moving up a straight road, so the direction of motion is upwards. Okay, and this is attached with a tow bar to a trailer. So this is your trailer attached with this tow bar. Okay, so just arrange it a bit more. Oh, it's trying to make it by on its own the way it was wanting to make. Okay, now what are the forces given? Let's note down the forces over it. Okay, the forces are, firstly, the weight of the car would be 1800, so this is 1800 G. Okay, and the weight of the trailer is 300 G. Now we have to resolve them. So resolving it will give you this is your perpendicular component, and this is your parallel to the plane component. This is perpendicular, this is the parallel to the component plane. Now just be writing what it would be. If this is your alpha, then this angle will also be alpha, and this one will also be alpha, so it will become 1800 G cos alpha 1800 g sine alpha, 300 g cos alpha, and 300 g sine alpha. Okay, this is it. Then resistance force. The resistance force acting on the car is 800 newtons, and the resistance force acting on the trailer is F newtons. Secondly, the driving force is 3000, so the driving force is making it move forward, so this must be your 3000 Newton would be the driving force. Okay, yeah. Any other force? Yeah, one more thing that should be written: the tension in the tow bar away from the car and away from the trailer. This would be your all of the forces. Now let's look into this, what to apply over here. Find the acceleration of the car. So when they say find the acceleration of the car, so this means that we are having some acceleration, final acceleration, and what would be the direction of the acceleration? Upwards. So whenever we have acceleration, what do we apply? Forward forces minus backward forces equals to ma. Okay, we are firstly, because we need the acceleration and the tension, so we can apply it on some particular particle, or we can like one particle or one body, and we can apply on the whole system as a whole. So first let's apply on the whole system. And what are the forward forces? Forward forces are 3000 plus this tension and tension will be cancelled out when we'll take the whole system, so I'm not writing that. The other forward forces, there is no other forward force. Backward forces are 800 Newton on car plus F, that is given to be 100. Okay, then plus 300 g sine alpha. Okay, these all are in the minus direction, and 1800 g sine alpha. That's it. Equals to ma. So what will be the total mass of the whole system? 300 plus 1800 times a. Okay, so from here we can directly find out a, because we already know alpha, and here we are having just sine alpha once. So using your, I'm writing this whole again in this one line: 3000 minus 800 minus 100 minus 300 g sine alpha is 0.05 minus 1800 g 0.05 equals 2100 a. So if we directly calculate it with a calculator, we are left with 1050 equals 2100 a, and acceleration will be equals to 1050 over 2100, that is 0.5. So we get the acceleration. Now we need to find the tension in the tow bar. So when we took the whole system, then we had this, we are not considering the tension because both the tensions are cancelled out. Okay, but if we will just apply this forward minus backward on any one of your bodies, then we can find out the tension from it. Okay, so for now we have applied it for whole system. Now let's apply let's apply it on the car. Forward minus backward equals MA. So what are the forward forces for car? 3000 newtons, and backward is 800 newton. Also the tension. Okay, and thirdly the 1800 G sine alpha. Okay, and equals to 1800 times the MA. So acceleration, now we found it to be 0.5. So from here, if we'll just take out T, so we'll get it to be 400 newtons. Okay, so this is all about your part A. Okay, now part B of the same question. It is given that instead the total work done against the F in moving a distance 50 meter up the road is 6000 joules. So this is your work done against friction. Okay, so this is work done against friction. The speed of the car at the start is 50, at the start of 50 meters is 20 meter per second. So this is the initial speed. Okay, and this is the distance it has covered. Energy method. We need to use the energy method to find the speed of the car at the end of the 50 meters. So yeah, we will be applying the energy method, but before that it is important to take this diagram with us below, so as to do some of your workings over it. Okay, so let's take that this both the bodies had covered a distance of 50 meters. Okay, so let's first take just the car. So the car has covered a distance 50 meter. First it was here and now it has reached here. Okay, so it has covered a distance of 50 meters. Now if it has covered a distance of 50 meters, so we are supposed to resolve it also. Okay, so it would be I guess it would be better if I use a little different color for this, more vibrant, so as to differentiate between them. Okay, so this is your 50 meters. And this is clearly not visible. So this is 50 meters distance covered. So this must be, if this is alpha, so this must be alpha, and this would be 50 sine alpha, and this must be 50 cos alpha. Okay, now what we need to do is to use the energy method. Okay, you can ignore the rest of the whole thing from here in doing the energy method thing. We won't be needing the rest of the things, so if you want to just get rid of these, you can. Okay, 300 G. Yeah, okay, now use the energy method. Using energy method, so what is energy method? The energy method is that potential energy of car plus potential energy of trailer before must be equals to potential energy of car plus potential energy of trailer after. Okay, yeah, it's better to do it downwards. I thought it would fit in here, but no, it would come in separate space more clearly and visibly. So potential energy plus potential energy before and after must be equals. So this is for car, this is for trailer. The same goes for here, potential energy for car after plus potential energy for trailer. Then kinetic energy for both before and kinetic energy for both after, and work done by driving force we don't need for both because only the car has a driving force. The trailer is just attached with the tow bar, so it doesn't have its own driving force. By car, and let's write it separately so that we are not confused, and work done by driving force for the trailer. Now it must be equals to work done against resistance by car plus work done by against resistance by trailer. This would be different for both of them. So let's substitute in the values. The potential energy for the car before. So if we take, there are two ways of doing it. You can take this height to be h1, okay, and this height to be h2, and obviously the potential energy of the car before would be equals to h1, and then it would be h1 plus 50 sine alpha. So on both sides it will be the same h1, so it will get cancelled. So it is always better in these type of energy method questions not to take the height from the ground level or the horizontal, but just to take the the corresponding heights, like the relevant heights, mean this body is how much above this previous body. Okay, so if I make you understand, like we are taking the relative heights, not the original heights from the ground, but we are just taking the relative height. So if it moves here, so it has moved some height above, and that is 50 sine alpha. Okay, so we are not taking it from the ground, but just the relative heights. So the potential energy of the car before, then you can take it to be 0, because initially it will be here. Okay, let me just get rid of this mess that I have created now. So 0 plus potential energy of the trailer initially. So trailer will also be at some height that is above the ground, so you can also take it to be 0. Okay, trailer is here and car is here, so both are at the relative height 0. Now when the distance 50 meter has covered, this trailer comes to, for example, this place after covering here distance, and this car comes here after traveling 50 meters. So now its relative height becomes 50 sine alpha above, and its relative height becomes 50 sine alpha above. Okay, obviously the body will be at the same, in the same line. I just made them above to differentiate their places. Okay, so we are just taking their relative heights from their previous heights. Okay, so because both are going to cover the same distance, 50 meter, they are attached. So potential energy of the car initial afterwards would be mg times 50 sine alpha, and the same goes for the trailer, mg sine alpha, 50 sine alpha. Okay, this is for car plus mass of trailer g times 50 sine alpha. This is for potential energy. Now let's work for the kinetic energies. Initially the kinetic energy of the car is given, the initial velocity is 20 meter per second. So it will be same for both. The kinetic energy will be same for both of them because both bodies are attached. So we can write it as half m of car plus trailer together 20 square. Okay, you can add both the masses, will be equals to half. The kinetic energy after would be also be the same for both because they both are attached to the tow bar. So car plus trailer v square. So v is that we need to find. Okay, then work done by driving force for the car, is it given? Work done by driving force. Driving force was given to be 3000 newtons. Okay, so 3000 times 50 meters it has traveled. So this is for work done by driving force for the car. For the trailer there is no driving force, so 0 times 50. Then secondly it will be work done against resistance for car. So work done against the resistance is given by 6000. Okay, joule is the 6000 for the car, and for the trailer they actually they have given here work done, like the force, previously the force was given to be 100 for the first part. Okay, so it was F Newton, now they have given you 6000, but for the trailer it for the trailer they have given it to be for the trailer 800 was on the car, so it will stay the same. Okay, 800 times 50 against resistance, so 800 times 50 for the car, 800 times 50. Okay, and this is for the trailer that is given, and this is for the car. If this is making you still it is confusing. As for the resistance, work done against the like the force, resistive force for the car is given to be 800 Newton in the start. Okay, so we are using the same 800 Newton for it, but they say now it is given, instead the total work done against is 6000 joules. So they have given 50 for 50 meters, they have now given it to be 6000 joules for this is, so this is for the trailer. Okay, so now we will put in the values, plug in the values and try and find it out. We need to just copy paste it once more because we need to substitute the masses. So mass of car is 1800, so 1800 G, and mass of trailer is 300 G, sorry, mgh. So this is not for the weight, but this is for the formula of, so 50 sine alpha plus 300 G 50 sine alpha for the trailer. Then what is the combined mass of both of them? That is 2100. So substitute in here half 2100 v u square and half 2100 v square. Okay, if for someone who is still confused in how do we get 6000 joules for the trailer, they say it is given that instead the total work done against F. So what was F? F was the force, resistive force against the trailer. Okay, so the resistive force for the trailer. So the work done against the resistance 6000 is for the trailer, and for the car we have to find, because we have F for it. It is 800. So we found it to be 800 times 50 for the car. Okay, so just solve it together. So it will become 40,000 is 40,000. So now when we solve this whole for velocity v, we will get it to be 21.1907. You can directly solve everything in the calculator. You can subtract, these all are added together, so you can just subtract, like keep this v square term on one side and subtract everything else on the other side, and then divide it by whatever is multiplied with it. So you will get this to be, this is the velocity for it. Okay, I hope you get this. This is like the easiest way of doing it. If you just apply this energy method over here, this one, for both the bodies, the potential energies, the kinetic energies, if you will substitute it in there, then you are able to do it effectively, clearly. Okay, this is all about your question number 6. Okay, I hope you get it.